Okay, so page 1 of this test review is kind of like page 1 of your exam. Biggest part of it is going to be this rational zeros theorem. When you see this phrase, rational zeros theorem, this is what you ought to be thinking of, your P's and Q's. This is from assignment 2.1. So a little hazy on that or a little fuzzy. Go back and watch the video on this in 2.1. All you need to do on question 1, 2, 3, 4, 5, and 6 is list the possible rational zeros. And then once you have a list of possibilities, that's the P and Q. P and Q are the possibilities. Once you have that list, then you just have to use the calculator to find out which ones from that list actually do work. So the factors of the constant at the end, that's where you get P, and then the factors of the leading coefficient, in this case 1, that's where you get Q. So P are the factors of 13, that's plus or minus 1, and plus or minus 13, and then the factors of Q are just plus or minus 1. So the actual list of all the possible rationals is P divided by Q. So if you take plus or minus 1, that's the first P number, and divide it by plus or minus 1 here, you're going to get plus or minus 1. And then if you take plus or minus 13 divided by plus or minus 1, you're going to get plus or minus 13. So this answers this part of the question, listing all the possible rational roots. Roots is the same as zeros. So you have to have this list on here to get credit for that part of the problem. The other part of the problem says then find the actual rational zeros. So the quickest way to do that, the way I've been showing you all unit, is to get on your graphing calculator, type it in, and graph it. So on the graph, it appears a positive 1. It appears the graph passes through positive 1. I'm just going to check that. So hit trace, then type in positive 1, and yep, it's 1, 0. So the graph is telling us that 1 works. So just to prove it beyond any doubt is you're going to have to do synthetic division. So drop down the 1. 1 times 1 is 1. Negative 5 plus 1 is negative 4. 1 times negative 4 is negative 4. 17 plus negative 4 is 13. 1 times 13 is 13. So we get a remainder of 0. And that proved it. Now, had there been others on the graph that worked from this list, you'd have to prove those as well. So this would get credit answering the other part of the question, then find the actual rational zeros. Okay. Skipping down here to 3 before we get over to question 2. So I'm going to do the same thing. We've got a list of P and Q values. So the values of P are going to come from here at the end. That's plus or minus 1, plus or minus 2. Factors of Q are going to come from the number in front of x to the third, that's 1, so it's plus or minus 1. So then P divided by Q is 1 divided by 1, which is plus or minus 1, and then 2 divided by 1, which is plus or minus 2. So again, that answers the first part of the question, listing all of the possible rational zeros. And you go to the calculator again, got to graph this thing. X to the third minus 8x squared minus 2, just to see if there's any that work here. So 1, 2, 3, 4, 5, 6, 7, 8. It looks like 8 way out there. If we check 8 though, 8 doesn't actually work. It's a little bit larger than 8. And there aren't any other x-intercepts on that graph here. So what that means is none of the zeros from this list work. That doesn't mean there aren't any zeros to the polynomial, it just means they're not rational. This list is only a list of possible rational zeros. Okay? So we made a list of possibilities, but when it says then find the actual rational zeros, there are none. No rational zeros. So we're not going to have to do synthetic division on this one to prove, because there aren't any ones, no rational zeros that work. It means they're going to be either irrational or imaginary. Here we go. So the difference here in question 2 is Q has a few more numbers. It's not a big deal. It's not a super hard question, but the difference is in how we form P divided by Q. So you just start with one number of P divided by everything in Q. Plus or minus 1 divided by plus or minus 1 is plus or minus 1. But now plus or minus 1 divided by plus or minus 2 is plus or minus 1/2. Now you move on to the next number of P. Plus or minus 7 divided by plus or minus 1 is plus or minus 7. And then plus or minus 7 divided by plus or minus 2 is plus or minus 7/2. So this, I don't want you to get confused here. Everybody look up at me for just a second. What is this right here?
Those are the possible.
These are the possible rational zeros. These are only possibilities. How do we know which one of these even work? You graph it. Okay? So you go back to your graph. And I wouldn't just blindly trust your calculator, because it kind of looks like what?
That's confusing. That looks like 2.8.
So if you hit trace, it kind of looks like 3, doesn't it? So I'm going to type in a 3 and hit enter. Is it 3? Okay. And that's the only x-intercept, right? Now we got to look, are there any of these numbers that look like?
No.
None of these, because 7/2 is 3.5. Is this 3.5? Well, we can type 3.5. Is that 3.5? It's not 3.5. Okay? None of them work. Now that doesn't mean it doesn't have any zeros. It has zeros. There's one right here, but you guys, this is a list of what type of zeros? Rational zeros. So it has zeros, they're just not rational. So what do we say here? These are the possibilities, and which one of them work? None of them work. So you'd say no rational zeros.
Wow, that's great.
But you need to understand, there still are zeros. And in fact, how many zeros are there going to be? There's going to be 3. They're just not rational. They're irrational or imaginary. Okay? That's a lot of how page 1 of your test is going to be. You make a list of possibilities. You find out which ones work using your graphing calculator. Any questions on that? The other part of page 1, I know you're not going to be happy about this, but the bottom half here, these are going to be a little more challenging. Okay? -4 and 3 plus I. Let's talk about 3 plus I. You're never just going to have 3 plus I. There's another one that pairs up with this. It's called the conjugate pair. It's going to be 3 minus I. So there's actually 2 parts to this question as well. It says find any remaining zeros. Did we find the remaining zeros? Yeah. But then it says find the polynomial. Okay. We have done this. We've taken a quiz on it, and it was on the quiz after that. Okay. Does this look familiar? You got to make your parentheses. What do we do with the parentheses? We've done this on 2 different quizzes, you guys. What are the factors going to be? We're going to have x plus 4.
No, x minus 3 plus I.
X minus 3 plus I, and then x minus 3 minus I. Now, I know we're going a little quick here. Let me just back up. How do I know it's x minus 3 and not x plus 3? Here's why. Okay? X equals 3 plus I, and x equals 3 minus I. If you want to transfer the 0 to a factor here, then you've got to get all of these terms to the same side as x. So you would subtract 3 on both sides. That's why it's x minus 3. And over here, you'd still subtract 3, and you would add I. So it's x minus 3 plus I. Over here, it's x minus 3 minus I. But you don't stop here. What do we have to do next? we had to distribute these. Okay? I would start with these two. Definitely start with those two. Okay. X times negative 3, and x times negative I. X squared minus 3x minus ix. And then if you distribute the negative 3, now you're going to have negative 3x plus 9. Pretty dang close. It's plus 3i. And then when you distribute the I, you're going to have plus ix minus 3i minus I squared.
So
I squared is negative 1. So if you're subtracting I squared, you're really subtracting negative 1. And what happens when you subtract negative 1? So this is really a plus 1 at the end. Minus I squared is really plus 1 at the same thing. So that takes care of that I. What else happens here?
get rid of the IX's.
The IX's are gone.
The 3I.
The 3i's are gone. So we have x squared minus 6x plus 10. I know it seems like we've already done a ton of work, but this problem's not done yet. What haven't we done?
X plus 4.
We've got that x plus 4, and then we distribute again. But now at least there's no more i's. So anyway, x times x squared, that's x to the third. X times negative 6x is negative 6 squared. X times 10 is 10x plus 4x squared minus 24x plus 40. And then you combine your like terms. We got x to the third minus 2x squared
Minus 30x.
minus 14x
Oh.
plus 40. Minus 14x, because we had a 10x and a negative 24x.
What about the negative 6x? Oh, that's squared.
That's squared, yeah. Okay, you guys, you have one question like this on page 1. Okay, like this here. You have one question like that. Okay, the other questions are going to be more like this, where you have the P's and Q's and you have to find which ones actually work. That's page 1. Okay, page 2, this right here, that's your answer. Yep, so before I move on, real quick, on number 8, take a look at number 8. Is it similar or way different than what we just did? So what about 2 minus I? The other one would be 2 plus I. And then what do? Same thing. You make your parentheses, you multiply it all together, you get the end result. Okay, let's go on to page 2. I don't think this is the most challenging page, but it is the one that's the most important in terms of what's coming up in the future in this course and just this material. This is really where you need to pay attention. This is where most of the points are going to come from on the test as well. So it says factor the polynomial, completely find all the zeros. Okay. It has 4 terms, doesn't it?
Yeah.
If that's the case, it's always worth a try to factor it by grouping before having to do all the synthetic division and all that stuff. You might as well try to factor it by grouping. It might work. And what can come out of this first group? And that leaves x. Come on, x plus y the plus 1. I took an x squared out of x squared, which means you're dividing x squared by x squared, so you leave
An X. Oh, yeah.
you leave the 1. X squared divided by x squared is 1. What can we pull out of that second group? If you factor out a 144 from this set of parentheses, you're going to be left with x
Plus 1.
plus 1. Well, what's the significance here? Look at what we have now.
It's 1.
X plus 1 matches. If they match, then it factors by grouping, and you don't have to do any of that synthetic division stuff. Okay? But you got to know how to proceed from here. We haven't factored anything yet. We're in the middle of factoring. How do we finish this up?
You gotta put the X squared plus 144.
X squared plus 144 is one of your factors. The other factor
X plus 1.
is x plus 1. Now, we already know that one of the zeros is x equals -1. That came from right here. What do we get out of that one? X squared plus 144. If it's x squared, it means it's quadratic. So you can either use a quadratic formula to get the zeros. But you notice this is kind of a different type of quadratic. Something's missing, right?
That's X equals 12i, right?
Yep. Plus or minus.
Yeah.
If that middle term's missing, just use the square root property. Turn this into x squared plus 144 equals 0. If you subtract 144 on both sides, you're going to get x squared equals -144. What's the square root of -144?
Plus or minus 12i.
Plus or minus 12i. Now, it says factor the polynomial completely. That also means you have to have all three factors. So now we can write f of x as x plus 1 times x minus 12i times x plus 12i.
Let me show you real quick an alternate way. If
Well, x minus 1, x equals -1 is the 0, but it came from a factor of x plus 1. If you don't want to have to try to worry about remembering how to factor by grouping, here's an alternative way. I'm going to erase all of this. This way I'm about to show you is the way that's going to work on the whole rest of this page anyway. So if you just want to learn one method and be done with it, then the method I'm about to show you works every time. Okay? It does involve the synthetic division stuff though. So if you didn't happen to catch that this one might factor by grouping, this is how you would do the problem. Type it in your calculator. Go ahead and do this. Follow along with me. Type in x to the third plus x squared plus 144x plus 144. What is it I'm looking for, by the way? Why graph it? What's that going to tell me? Say that loud. It's going to tell us what some of the zeros might be. Does the graph tell us anything here?
Yeah.
Isn't it telling us -1? Looks like it. So if I hit trace and then type in -1, is it really -1?
Yes, it is.
Yeah, it is. So I know -1 works. We all know -1 works now. So I'm going to do -1 and do synthetic division on -1. 1, 1, 144, 144. Drop down the 1, multiply, add. Okay, now we have -1 times 0, which is 0. 144 plus 0 is 144. Times -1 is -144. And we get 0. Okay, it's been a couple of days since we talked about this, but we spent 2 days going over this, you guys. 2 full class periods going over this. What has this proved to us right here? It's proved that -1 is a 0, but it's also done something more important. What is this right here? It's the other factor, exactly. So now we could say x plus 1 times x squared plus. So we just factored this without having to factor by grouping. We factored using synthetic division. It gave us the same result.
you've got to decide which is going to be easier for you. This method of synthetic division will work every time. Factor by grouping only works some of the time.
So where do we go from here?
Quadratic equation.
unless it's missing that middle term.
Yeah.
In that case, I would just use square roots. X squared plus 144 equals 0. Subtract 144. Square root, and we get the same exact answer. X equals plus or minus 12i. So then the factors are x plus 1, x minus 12i, x plus 12i. Okay. Let's just kind of skip around here. Let's go over to 13. Let's see if we can handle 13. I'm not even going to bother trying to factor it by grouping. Okay? I'm not even going to bother. Where's the first place you should go on this problem? Graphing calculator to find zeros that might work. Once we find zeros that work, we do synthetic division to find all the other factors. What's it looking like? Oh, there's a lot of them there. Kind of hard to see. Looks like maybe -3. I'm going to type in -3. Nope, on the graph. This is trace and then type in -3. -3 work? Yeah, it does. -3 works. So I'm going to type in -3 and do synthetic division.
What if there's multiple things now? Pick one.
Just pick one of them. 'Cause I think -1 works as well, didn't it?
Yeah.
So you could have used -1, your end result would have been the same. So doing the synthetic division here. You're going to be successful on this page of the test as long as you understand this very important principle, like I tried to explain before. This process has proved that -3 works. We already knew it worked because the graph said it did. More importantly, it gave us this right here, which is what? These aren't zeros right here.
It's another equation.
This is the other factor. Yep, it's another expression. It's the other factor. Right now we can say that this expression that we had can be written as x plus 3. That came from right here. If -3 works, then x plus 3 is a factor. And then these numbers tell us the other factor, x squared plus 2x plus 1. Now, we have that dang old middle term. So like up here where the middle term was missing, we can't just use squares. If that middle term is here, what do we do? Quadratic formula. X equals, yeah. If 0 on your graph, if so if there was like a 0 right here, you wouldn't put anything for x. So x equals the opposite of b, plus or minus the square root. You're going to have to know this formula. I'm not going to have it on the board. You learned it last year in secondary 2. We've done it like for 3 weeks in a row here. You should know it by now. B squared minus 4 times A times C all over 2A. And what is 4 minus 4? Square root of 0? So this is what we have. We have x equals -2 plus or minus 0. But if it's just plus or minus 0, does that mean anything? I would just get rid of it then. You don't need plus or minus 0. But that's all divided by 2, and then -2 over 2 is -1. Now we got to count though. We knew that -3 works, and now we've proved that -1 works. Kind of seems like we're missing one, right? But if you go back to the graph, did you notice anything on the graph that was kind of weird regarding -1? It bounces, which means it has multiplicity of 2.
So negative 1 really counts as 2 zeros because it has multiplicity. That counts as 1. So how many do we really have?
3.
We really do have all 3 because negative 1 counts as 2 zeros.
Negative 1, negative 1.
Exactly. It's negative 3, negative 1, and negative 1 again. Okay. Let's do one more here real quick. Let's do 14. I know it looks different because it's got that 5 in front. It's no different. What's the first thing we did on all the other ones? Graphed it. Let's go to the graphing calculator. Ooh, how many zeros are we looking for, by the way, at number 54? We're looking for 4 this time. So, hopefully we get them all. 5x to the 4 minus 36 x squared minus 81. Is a graph telling us anything useful?
Yeah, 3, negative 3.
Okay, so I'm going to list both of those, 3 and negative 3. Now just choose one. Which one do we want to use first? Doesn't matter. 3? All right. I can see this being a huge problem on your test. Some of you have already noticed it. If you don't notice it, you're going to get way screwed up here. What am I talking about? What should you have noticed? You're missing an x to the third term, and what else are you missing? An x term. What do you do when you're missing terms in synthetic division? You got to put a 0 there. So it's 5, and then a 0, and then a negative 36, and then a 0, and then a negative 81. Now you do the synthetic division. Ooh, big numbers. 45 minus 36. 9 times 3 is 27. 0 plus 27 is 27. 3 times 27 is positive 81. Now the point wasn't to prove the 3 worked. We already knew it worked. The point was to get these numbers here. Okay.
We've done a few x to the 4th equations, not many, so you might not remember, but we had another 0 that worked, right? Negative 3. So we're going to do synthetic division again with negative 3, but not on the original polynomial numbers. We're going to use
these numbers for synthetic division. So now we got negative 3, 5, 15, 9, 27. We know it's going to work. We know we're going to get a remainder of 0. The point wasn't to show that we're going to get a remainder of 0. The point was to get this right here, those numbers. Okay? Here's what I would now do. If 3 worked and negative 3 worked, that means that x minus 3 and x plus 3 are factors. And then these numbers tell you what the last factor is. 5x squared plus 9. So it's quadratic.
But it's one of those weird type of quadratics where something's missing, right? What's missing? That x term is missing. So I would use quadratic formula. You could if you wanted, but
If that x or middle term is missing, I would just set this equal to 0. 5x squared plus 9 equals 0. Now what? Subtract 9, so we have 5x squared equals negative 9. We can't square root quite yet.
Divide by 5.
Divide by 5. Now we have x squared equals negative 9/5. So now we can square root that. I'm not going to be too picky here. Really, the only problem is we're squaring a negative number. How do we get rid of a negative sign in there? So I would be okay with this. X equals plus or minus I times the square root of
9/3.
I'd be alright with it. There are things we could do to simplify that. Technically, that's not fully simplified. We really didn't talk about how to simplify squares that much. The only thing I would be concerned about, if you leave a negative sign in there, I'm going to dock a point off, because you know not to leave a negative inside of there, right? Other than that, I'd be completely fine with that answer. Okay, how many zeros were there, though? We got to make sure we got 2 of them over here. We had 2 of them over there, so we got all 4 of them, don't we? So this is going to be page 2.
before the bell rings, let's just quickly go through the steps. All of the problems on page 2 can be solved using the same steps. The first thing we always did was graph it to find which zeros work. Once we find ones that work, then we did synthetic division until we got a quadratic factor. Like here we got a quadratic, or up there we got a quadratic. Once we got it down to a quadratic, we either used a quadratic formula or used square roots. Did you have a question? Yep. Hey guys, hold up. There is one more page. We don't have time for it, but it's the page we just finished. So I just want to quickly run through it. I've got 1 minute. So you guys just look up here at the board. You ready? What kind of polynomial are you going to try to find if there's 4 points? Cubic. Do you have to do much work to find that polynomial? No. Calculator does it all for you. What about number 17? What kind of polynomial? Cubic again. Okay? This is one of those on number 18 where I actually have to make a prediction. I told you to let x equal the years past 1960. So to answer this question right here, what's the milk production in 2015? How many years is that beyond 1960? It's 55. So when you're looking at the graph and you want to know the x value, you're going to use x equals 55 on this graph for that table. Does that make sense? That's page 3. You've got to make a couple of polynomials and then answer a question about a table. Okay? Which is pretty much all calculator work.